All right, good afternoon. So this is the mathematics of geodesy. So the last lecture that we have discussed is all about the positioning of the geodesy. So before we proceed to the next topic, let's have first the mathematics in geodesy. So this is the basic foundation in computing some of the computation and transformation of coordinates in geodesy. So let's start with the mathematics in geodesy. So this is just the review of the spherical trigonometry, if ever you discuss it in your past subject in Math Enhancement 1 or I think Math Enhancement 2. So the very basic foundation is the knowledge on the spherical trigonometry. Okay, so I have here the outline of this topic. So we are going to discuss here reduction of scale. You already know this and you discussed already this one in Carto. We have computing the length of the parallel, mathematics of sphere, including the measurement of the distance, the surface area of the sphere, the surface area of a zone, and computation of short distances in a globe. So we are going also to discuss what is a Napier's rule. So uh, this is a quite a tips on how are we going to solve the parts, the remaining parts, or the lost part of a spherical triangle with the following the rule, which is easier to use if we are going to compute the remaining part of the spherical triangle. We have also a brief introduction of our going to compute the area of a spherical triangle, just in case your instructor in your math enhancement or math enhancement 2 wasn't able to discuss and wasn't able to integrate spherical trigonometry in your subject. So we're going to discuss this one. And another is the spherical excess and the error of closure of the spherical excess. So all of this knowledge that we are going to employ here is very important as we go on with the other topics that we are future in the future we are going to tackle in the geodesy subject. Okay, let's start with the reduction scale. So in the cartography, you discussed with the how are we going to compute the scale of the map. So basically, this is known as the reduction scale. Since the word reduction reduce the you reduce the actual area or actual length on the ground on a map. So that's why we change the measurement has been changed, but the equivalent is the same. That is known as the scale. So the reduction scale is also known as the representative fraction. So this is given by the formula, the globe distance. When you say the globe distance, the object, the globe itself. So the representation of the globe, kung nakita na kamon globe, and over the earth distance. This is the corresponding distance that we can measure on a globe and the corresponding distance mismo sa surface ng earth. So we can determine the scale by just dividing the globe distance over the earth distance. So I have here a sample problem on this one. Okay, so along cross-country road, so there's a road cross-country, so from one country to another, was found to be 680 kilometers in length. So sobrang haba ng kalsada, 680 kilometers in length. So the distance, the distance between the end point to end point of the road, so the starting point of the road to the other end of the road. It was represented in the globe with a reduction scale of 1:200,000, which means my globe, we don't know the circumference of that globe. So if the scale of that globe, the actual 680 kilometer is being projected on a certain object, which is the globe, in this scale is 1:200,000. Now, determine its globe distance. So gano'n siya ka-liit lang kung titingnan sa globe. And the globe to map scale, it is found out to be 17.24 centimeter on a map. So we are going to determine the globe distance and the map distance. So by the formula, we have the reduction scale. We have given tayo ng Earth distance, which is 680 kilometer. So ito yung actual length mismo ng road, the cross-country road. We have here 680 kilometer. Meron tayong representative fraction. So this is the globe distance over the Earth distance na given na, which is 1:200,000. We have another given is the map distance. Meron siyang flat na map. So sinukat niya yung 680 kilometer doon sa map, and it was found out 17.24 lang yung length niya on that map. So yung required is to determine the globe distance and yung scale from globe to a map. So iba yung globe, since yung globe yung kulay blue, so, and into map. So what is the scale? So before we can determine the scale of globe to map, we are going to determine first the distance of that road in the globe. So we are going to compute the globe distance. So since we have already the Earth's distance and we already have the representative fraction, then we can employ that formula and then we can determine directly the globe distance. So I have here the solution. So I have here, since reduction scale, this is the formula. So given na yung ating, okay, for a while. Okay. Since given na yung ating reduction scale, which is equal to 1:200,000, we have the Earth distance of that road, which is 680. Then we can compute na directly the globe distance. So we have here, so by just cross multiply, we have here, we can determine the globe distance by multiplying 1 times 680 over the 200,000. So it says, so substitute and then simplify this one, we can have the globe distance. So the globe distance of that 680 kilometers on the ground is equivalent only 340 centimeter on the globe. Okay, so now our next target is to determine the scale on that globe to the map. So we are given sa map, kung makikita sa map, 17 centimeter lang yung length ng globe. However, dun sa globe is 340 centimeters. So we are going to compute ano ba yung scale difference or ano yung scale mismo ng globe to the map. Okay. So similar din yung concept in computing the scale, which is equivalent to map distance over the globe distance. Since given na yung ating globe distance and given na yung scale, we're going to compute this one. Given na yung map distance, the given kanina, which is 17.4, and we have here globe distance, which is 340. So just substitute the values. We can have here 17.24 over 340. So the scale is 0.05. So this is almost equivalent to 1:100 or 1:50. Okay. So just employ this reduction formula. Okay, let's move to the next. So the next topic will be okay. So the computing the length of a parallel. So what is a parallel? So if you can see a globe or the surface of the Earth, which is we assume to be a sphere. So in the illustration, I have here the, so if this is the top view of the surface of the Earth. Ang top view to. And then, right here, kung this is the top view, so nakikita, andito yung ating North Pole. Kung sa taas tayo, imagine, nasa taas yung ating visual. This is the North Pole. So if this is the North Pole, this one is our equator. So this is the equator, which means this angle here, so this angle to here, or all around this, in this area with respect to a reference meridian is called this theta here is called the longitude pag naka-top view tayo. So pag naka-side view, so imagine naka-side view. So pag side view naman, so makikita natin is this portion here now becomes the equator since naka-side view siya. If this is the equator, and if we draw an angle here, from here to here, this is now the latitude. Okay. So this line, which is parallel to the equator, diba? Several lines along here and several lines along here. So these are called parallel or the parallels. So this one are called parallel as long as it is parallel to the equator of the Earth. So the angle that is cast from the equator above, we all know that is what we call the latitude. Now, our goal is to compute or determine the length of the parallel of a certain sphere. So how are we going to compute the length of this parallel, given that we have the latitude of that parallel? For example, we are going to compute this parallel. So we are going to, we need to be sure that we already know the latitude of that parallel. Okay? So if this is the, we have the second parallel, this one. So in order to get this one, we need to compute its latitude. So by just simply, I need to change the pen. So if this is our target na parallel, now we can have the latitude. So this is our latitude to be this. We can only determine the length of the parallel if given yung latitude mismo ng parallel. Okay, so let's have an example. So by this here, so we can compute the length of the parallel using this formula. The length of the equator times the cosine of phi. So as you can see in this illustration, meron tayo ditong parallel, which is this one, this line along here. So we can create a right triangle if we take half of that circle here. So this is now the radius of that sphere, which is denoted as R. And also this one is the radius of the sphere. So we have here the latitude of that certain parallel. Diba? This is the latitude of this parallel. So we are going to compute how long is this parallel given we have the theta. So by the distance formula, we can compute this R, and we can compute also the length of this line and the length of this line here. So we kakat natin siya, lagay natin siya dito. And then this is R. And then we have if this is theta, then this is also equivalent to theta. Okay, right? So we are given here R is equals to sine 1 since sine is so sine of your angle is equals to opposite over hypotenuse. Since meron tayo ditong, dito ko muna yung computation. We need to change the pen. But sine of the angle equals to opposite over the adjacent, the hypotenuse. So yung ating opposite of the angle ay over hypotenuse is r. So we can compute the length of this side is equivalent to r sine of the theta. Okay, if we are going to compute the length of the parallel, so this is just equal to the length of the equator times the cosine of the latitude of that angle. So if we are going to compute the circumference of that parallel, since circular to, this is just a side view. The side view lang to at kaya straight line. If we take a look of the whole sphere, that is circle yung kabuusan, ang kabuusan nga parallel. So that if you are going to compute the circumference, this is just equal to 2 pi r, where r, that is the radius of the sphere or the radius of the earth, which is given by r cosine of the latitude. So therefore, the circumference of your parallel is given by 2 pi r cosine of the latitude. Okay. So let's try a sample problem here. Considering the meridian between two places, so meron to dalawang posisyon. We have 80 degrees west yung isa, and yung pangalawang point ay located at 150 degrees west. Okay, so we have 2 points which is located in different meridians. So yung isang point is located at 80 degrees west. Yung pangalawang point is 105 degrees west. So yung required is to determine the distance between two places measured with respect to the equator. So can you imagine the problem? So merong dalawang point, iba-ibang meridian. So yung isa is located at 80 degrees west and yung isa is located at 105 degrees west. So yung question is, determine natin yung distance from that point on the 80 degrees west and yung hanggang doon sa 105 degrees west. Okay. So we have here an illustration. If this is the north or the North Pole, for example. So trajectory ng North Pole is we have here 0 yung ang ating longitude. So let's say this is the prime meridian, which is 0 yung ating Greenwich meridian, or yung prime meridian, which is 0 yung ating longitude. So since west yung ating given na angle, so papunta siya doon. So andito, for sure, andito yung 80. So this, andito, for example, nandito si 105. So lalagyan natin ng label. We have here, this is 80 and 105. So now the question is, just determine the distance between the two places measured with respect to the equator. So let's just say, yung longitude dito, latitude dito is 0. So which means along the equator lang siya. Have here. So how are we going to determine the distance between these two? So paano natin ma-determine yung distance between the two? Okay, so we all know that the length of the parallel is equivalent to the length of the equator times the cosine of the latitude. And we already know that the circumference of the parallel is given by 2 pi r cosine of the latitude. So we have here distance of the AB So we're going first to determine the difference in the longitude. We determine na muna how far is this to. So we can determine that by taking the difference of their longitude. So just 105 degree minus 80. So that will be how long is that in degrees times 2 pi r. What is it? Divided by the whole circumference of the parallel. So this is difference in longitude. This is 105 minus 80 times 2 pi r over yung circumference mismo ng sphere since nasa equator siya. So can you solve this by 105 degrees minus 80 times 2 pi r, where r, so this is just estimated or the average radius of the Earth. So if you encounter this problem, tapos walang given na r, you can use r as 6,400 kilometers. So this is the very close. And some of the sample problems are using this value as the value of the radius of the Earth. Okay, so why circumference is equal to 360 degrees? This is because nasa equator siya. So one revolution of that along the equator, so that is 360 degrees. So just simplify this one. We can compute distance AV equivalent to 2,792.53 kilometers. So check if my solution is correct. If not, you can comment this on the comment box on the where I'm going to post this video. Okay, so you check if the answer is correct, 2,792.53. So now the position of AB is on the equator. What if this AB is located somewhere here? Let's say, for example, this is latitude 40 degrees. Or what if AB is located here? For example, yung latitude niya dito is around mga 70 degrees na. So is the distance still the same? Same lang ba na 2,792.53 kilometer? So as you can say, imagine this is equator, and can we say that AB here is still the same? Maski isang meridian lang siya. So let's take a look to the next problem. So considering the same lang din, so considering the meridian between the two places is 80 degrees west and 105, so the same lang yung problem. But determine the distance between two places measured with respect to the 40th parallel north. What does it mean by 40th parallel north? So which means from the north, pang 40th parallel siya, or yung kanyang latitude of that point is equivalent to 40 degrees. Okay, so since kanina, di ba, 105 degrees minus 80 times 2 pi r lang yun. So since we have now the parallel, so we have now the latitude. So we employ 2. New formula is, we have here, and I change ko muna yung 10. We have here the difference in longitude. Difference in longitude times 2 pi r cosine of your theta. So this is now the latitude of that parallel divided by, again, the circumference of the sphere. So if you simplify this formula, this is 105 minus 80 times 2 pi r cosine of the 40. So distance AB is equivalent to 2139.20. So na-solve natin kanina is 2792.5, I guess, kilometer versus 2139.20 kilometer. So this is large. There is large difference between. Since ito ay nasa 0 degrees latitude, this is 40 degrees latitude. Diba yung ating meridian from the equator, nagiging closer siya papunta doon sa North Pole. So that's why if the object, if the position of 2 points decreases until magiging doon sa North Pole, since yung meridian get closer upon reaching the North Pole. Okay? So you try to check what if on the 80 degrees latitude, mag-i-increase ba? So you check also. So you substitute lang the values and you differentiate what happens to the distance between AB if they get closer to the North Pole or to the 90 degrees latitude. Okay, so I hope that is clear. So let's have another problem. Using the given situation the same with the previous problem, if the map having a representative fraction 1:20 million shows the 40th parallel of a standard line, the distance between cities measured along the parallel will be. So if the map ko no having a scale of 1:20 million, and then we are going to compute now the distance between cities measured along the parallel. So here, just employ the reduction scale since meron tayong scale. That is equal to globe distance over the Earth distance. Since na-solve natin yung ating Earth distance in the problem kanina, so we just reduction scale, which is 1:20 million, is equal to the globe distance and the map distance over yung ating Earth distance in the 40th parallel. So, kung makikita natin sa map, gaan na lang what is the distance between these 2 points on a map if yung map ay may 1:20 million scale. And alam natin na yung ground distance o yung actual distance ng point is 2,139.20 kilometer. So, just cross-multiply this one. We can determine the map distance is 10.64 centimeter. So, meron kayong map, ma-measure nyo at the 40th parallel, 10.64 lang yung layo ng dalawang point. Okay? So, that is now how are we going to apply the knowledge on the reduction scale or yung representative fraction. Okay? Let's move. So, another mathematics of sphere is computing the surface area ng sphere. So, given that yung surface area ng sphere is equals to 4 pi r squared. So, paano ba natin na-compute? How did they get the value of the surface area, which is 4 pi r squared? So, yung surface area ng sphere o yung kabubuang area ng sphere is derived from the formula in computing the surface or area of a cylinder. So, for example, we have here the cylinder, and then we have this sphere, tapos pinasok natin yung sphere on that cylinder, tapos nag-fit siya. So, imagine a ball is being fit on a cylinder. So, parang ganun yung concept. So, now, makikita natin if naka-fit to since yung top mismo ng sphere touches the upper portion of that sphere, and then yung lower portion mismo ng sphere touches the base of that of this cylinder. So which means yung radius ng cylinder is magiging radius din ng sphere, diba? And then, similar with this one, since ito ay half ng length ng sphere, ito ay similar din sa radius ng sphere. Okay. Then, if this is R, so this is also equal to R. If this is R, then from here to here is also equivalent to the value of R. So again, it is derived from the surface area of the cylinder, which is 2 pi R squared. Yung area ng cylinder is given only 2 pi R squared. And then, since dalawa yung ating R, the portion here is 1, and another portion, so that's why meron tayong 2R. So, we multiply 2 pi R times 2 pi R times 2R. So, this will become 2 pi R squared. So, this is now the surface area of a sphere. So, another is, we have already done with the circumference. We have the surface area. So, this next is we are going to discuss a zone. So, I think you are not familiar with the zone. So, when you say zone, meron tayong illustration dito. So, imagine a sphere, yung upper portion or either yung lower portion, this is called the zone. Ito yung area sa taas or sa baba. Pwede din siya at this portion here. We're going to have an illustration. So, if this is the sphere, meron tayo ditong equator. And then we have here a certain parallel. And then a portion from the north until doon sa ating parallel. So this portion here, ito is called the zone. So we take the shaded part, that is the zone. So how are we going to compute the surface area of this part lang, hindi yung kabuuang sphere? So either it can be computed by subtracting the area of the southern or northern hemisphere. So ito yung whole sphere. This is the southern portion, this is the northern portion. From equator hanggang pataas, this is the northern. And ito naman ay si southern portion of that sphere. This is the southern portion. It depends upon kung saan nakalocate yung ating zone. It's either kung northern or kung sa southern sphere. So let's just say for this example, nasa north yung ating zone. So we can use the northern portion. Let's take a look. Computed by subtracting the area of the southern and the northern hemisphere by the surface area where the parallel or the base o yung parallel of the zone lies. So yung we are referring to the latitude. So this is the situation. Andito yung ating zone. This is the angle or the area which hanggang doon yung kanyang base ng zone. So yung base ng zone, so this is now the parallel. So since parallel to, meron siyang corresponding niya na latitude. So we can compute the area of this portion here by just 4 pi r squared. This is the area of the whole sphere. Tapos, since half lang yung ating target, divided by 2 natin siya. So, 4 pi r squared divided by 2, that is, ang answer nito is the area of the northern hemisphere or yung southern hemisphere. So, minus 2 pi r squared sine of your theta. So, what is 2 pi r squared sine of your theta? This is the area here, diba? 2 pi r squared sine of your theta. Since yung 2 pi r squared cosine of theta is the circumference of the parallel. So, if 2 pi r squared sine theta, so this is 2 pi r squared sine theta, this area here. So, if the whole hemisphere, itong northern hemisphere, minus this portion, So the answer would be only the left one, which is called the zone. So where theta is your latitude of the base of the zone, so we can compute by just direct substitution, we can determine the value or the area of the zone. So I have here a sample problem. So determine the area of the Earth's surface which lies within the Arctic Circle, 56 degrees latitude. So meaning yung base niya ay 56 degrees latitude. The plane on the Arctic Circle is parallel to the equator. So merong yung plane mismo ng latitude ay nakaparallel sa equator. So madali lang natin i-solve. Assume that the radius of the Earth is equal to 6079 kilometers. So by employing the formula, which is 4 pi r squared over 2 minus 2 pi r squared sine theta. So you can compute, cancel out this one. So this will have 2 pi r squared na lang minus 2 pi r squared sine theta. Since similar siya na may 2 pi r squared, another 2 pi r squared, we can factor out 2 pi r squared. So the remaining would be 1 minus sine theta na lang. So direct substitution, or you can directly substitute the values here. So I just simplify this one. So 2 pi r squared times 1 minus sine of the latitude. So the area along the zone here on the Arctic is equivalent to this value. So that is equivalent to 43,710,497 kilometer squared. So this is the area of the Arctic from the 56 degrees latitude. Right? So I'm just going to cut the videos here. This is separate videos, I think, para hindi masyadong mataas. So next, we'll be going to discuss the law of cosine for the spherical trigonometry. And we're going to continue discussing the Napier's rule, the area of the spherical triangle, and the area and spherical excess of the spherical triangle. So this videos will end only here. So